Configure routers to use point-to-point protocol as their one protocol using Chap authentication. Okay, first of all, configure branch 1. Enable verify configurations with show running config command. Gigabit 00 already configured. Is this? Also, gigabit serial 010 already configured. Is this? Okay. So configure point-to-point protocol on serial 010. Configure terminal interface serial 010. Encapsulation point-to-point protocol. Okay, but for the Chap authentication, use the following command: point-to-point protocol authentication Chap. Exit, then create a username. Okay, the username of the remote site is ISP. Username ISP. And password, for example, Cisco. Okay, and set the local user host name and, for example, branch 1. Host name branch 1. Okay, now this router is branch 1. Okay, now configure ISP. Enable configure terminal. Set the host name ISP. Okay, ready. And verify configuration. Show running config. Okay, both serial interfaces are already configured. Serial 010 with this IP address. This is serial 010. Face in branch 1. Serial 11 with this another IP address. Serial 011. Okay, on the branch 2 side. Now configure. First of all, serial 10 facing branch 1. Configure terminal. Interface serial 010. Okay. Encapsulation. Point-to-point protocol. Point-to-point protocol authentication. Chap. Okay, exit. Then create the username for the remote site, branch 1. Username branch 1. I prefer to use case sensitive, and password, the same password, Cisco. Okay. Okay, and verify the ping to the another side. Ping to branch 1. Okay, ping fails. Okay, and wait a moment and wait to serial 010 change its state to up. Okay, and repeat the ping. Okay, go to branch 1. Wait a moment. Try the ping again. Go to branch 1 and copy running config to startup config. Enter to confirm. Okay, then reload to restart. Okay, serial 10 change state to up. So from ISP ping to branch 1, and ping is successful. Okay. Now configure ISP serial 011. Configure terminal interface serial 011 encapsulation. Point-to-point protocol, point-to-point authentication, Chap exit, and configure the remote site, the username, for example, branch 2, password can be Cisco. Okay, and go to branch 2 and configure serial 010. Okay, enable configure show running config to verify configurations. IP addresses already configured. Configure terminal hostname branch 2. Now configure serial 010. Okay, sorry, interface serial 010 encapsulation point-to-point protocol authentication Chap, and create the username for ISP. Exit username ISP password Cisco. Okay. And wait a moment, but I prefer to reload the device and copy running config to startup config. Enter, then reload. Okay, serial 010 change state to up and enable ping the another side. Okay, for example, 198, 133, 219, and ISP interface is 86. 86 success. Okay, and configure the Gre tunnel between branch 1 and branch 2. Okay, and so you can configure a tunnel between those devices. Okay, this is the tunnel. Okay, the Gre tunnel, and okay, but Okay, but before to configure the Gre tunnel, try to ping from branch 1 to branch 2. Okay, enable. First of all, ping ISP, ping 209.165.201.2 ISP success. Another interface on ISP that is 198.133.219.86. Okay, ping fails. Try to ping branch 2, 87. Ping will fail. Okay, and from branch 2, ping ISP that is 86 success. Ping the another interface on ISP 209.165.201.2. Ping will fail. And ping branch 1, ping also will fail. Okay, so you need to configure the routing to permit the connection between branch 1 and branch 2, and then configure the Gre tunnel. Okay, so the connectivity between branch 1 and branch 2 is a requirement. Go to branch 1 and configure static route to reach branch 2. Configure terminal. You can configure on the default route, IP route. And the next hop IP address is the ISP, that is 209.165.201 and 2. On branch 2, configure terminal IP route, the default static route, and the NetHub IP address that is ISP 198.133.219.86. Now, from branch 1 and try to ping branch 2. Is 87 success, and from branch 2 try to ping branch 1. Is this 201.1 success. Now configure the Gre tunnel. Okay, go to branch 1 and configure terminal interface tunnel 0, tunnel source. Tunnel source is for example, my local interface serial 010. Okay, the tunnel destination, the remote IP address, this interface on branch 2, the 87 IP, 198.133.219.87. And the tunnel Gre tunnel protocol Gre IP. Okay, more question is the mode. Okay, tunnel mode Gre IP. Okay, and configure branch 2. Configure terminal interface tunnel 0. tunnel source, serial 010, the local interface, and the destination, the IP on branch 1, 209.165.201.1. Okay, and the tunnel modes GRE IP. Okay. Okay, but configure IP addresses on the tunnel. Okay. For example, the tunnel will be this this network 1010.030. Okay, branch 1 will be 1 and branch 2 number 2. Okay, enter to interface tunnel 0 and set the IP address 1010.10.1 subnet mask 30, that is 252, and on branch 2 tunnel 0 IP address 1010.10.2 252. Okay, and verify connectivity ping to branch 1 but and the tunnel interface success, and go to branch 1 and ping the tunnel interface on branch 2 success. Very nice. Now single layer OSPF as the routing protocol. Okay, on branch 1 configure OSPF, configure terminal router OSPF process ID 1, router ID, for example, 1, and do show IP route connected to be the directly connected networks. Okay, and notify the tunnel 0 and the gigabit 00. Okay, only these two, because you need to use the tunnel and the LAN interface. Okay, network 10.10.10.0, wildcard for 30 is this area 0, and for the local network 192.168.1.0 use this wildcard and also on area 0. Okay, and set the passive interface gigabit 00. Now configure branch 2 the same way, configure terminal router OSPF process ID 1, set the router ID 2, do show IP route connected, and notify the tunnel in the gigabit network. The tunnel area 0. Net, okay, found the adjacency network, the local 192.168.3.0 wildcard area 0. Set the passive interface gigabit 00. Okay, verify the routing table on branch 1. I show IP routes. Okay, this is the network on the tunnel. This network, this is the local network. This network, this is the remote network on branch 2, the LAN on branch 2. the directly connected networks to serial interface for serial interfaces. Okay, and also on branch 2, show IP route. You can see the remote network, the LAN on branch 1. These are the PCs pinged to 3.2 PC4. The another side 3.2. Success. This is doesn't have an IP address. I will configure 192.168.3.3, 24, 192.168.3.1, the default gateway, and ping to 3.3. Success. PC6 3.4. 3.1, default gateway, and ping to 3.4. Success. And the server 3.10. Success. Okay. This is the 192.168.1.2. Configure this 1.3 default gateway 1.1. This 1.4 subnet mask default gateway 1.1. PC3 1.5 1.1. And try from PC4 ping those PCs on the another side. 1.2 success. 1.3 success. 1.4 success. Okay, finally, extended named IPv4 access list to permit branch 1 access to the web server located in branch 2 but deny access to the FTP server on the same server. Okay, the server on services HTTP enable, FTP enable, okay, for example, from PC0 access to the 3.10, that is the web server, and success. And if you if you will use FTP, use this common FTP 3.10, username Cisco, password Cisco. Okay, this is the logged in, success. Okay, ls or dir, and you can see all files on the web server, exit or quit. Okay, so you can access the web services and FTP services. But create the extended named access list to permit branch 1 all network on branch 1 access to the web server but deny access to FTP. Okay, on branch 1 configure terminal, create an extended access list. For example, IP access list extended. The name can be web, yes, no, no, FTP, no. Okay, permit web but deny FTP. Okay, but this access list is not specifying another protocols. Only permit branch 1 access to the web server but deny FTP. This access list is not specifying the another protocols like ICMP, TFTP or DNS. Okay, only says permit web and deny FTP. So you can do the following: deny FTP and include any other protocol or service. Okay, and obviously it's included the web. Okay, deny mark question to be the options. FTP uses TCP, so use deny TCP mark question to the source address, and any source address or local branch. The source address of branch is the LAN of branch 1 is 192.168.1.0, and wildcard for that is this. Mark question to be the options and specify the destination address. The destination address is the server 3.10, but specify the host. It's a single host 192.168.3.10. Mark question to be the options and use the match only packets on the given port number. Use this equivalent the 20 and port 21. Okay. Finally, permit IP from any to any, and verify the access list. Show access list. Okay, the extended access list is called web. Yes, FTP no. Deny TCP. The source is the LAN on branch 1 and the destination the web server. It uses the port 20 that is used on FTP for control, and deny TCP from LAN on branch 1 to the destination host 3.10 and port 21 that is the for data and is blocked, and permit web and ICMP and any other service protocol with this command. But you need to apply this on gigabit 00 on router 1. Configure terminal interface gigabit 00 and IP access group. The name is web, yes, FTP no. Incoming traffic, because this is the source and this is the destination, and the traffic is incoming on gigabit 00, so it's incoming in. Now test, go to PC0, enter the web server 3.10, success, ping 3.10, Control C, ping 3.10, success, but now try to access with FTP to 3.10, just trying to connect and disconnecting, timeout. Okay, very nice.